question number 21 and June 21, paper 1, 2, and question 29, obviously. Now, in this question, they have given us two wavelengths for 20 nanometer and 630 nanometer, which are incident normally on a diffraction grating. Now they say the diffraction maxima for the two wavelengths overlap only at angles of 31 degrees for the direction of the incident light beam. Now they have not given us which diffraction maxima, third and fourth, fourth and fifth, fourth and seventh. So they have not given any information about that. Now first we'll think the two diffraction maxima are the consecutive ones. And if we are unable to get a whole number for that, then we'll solve it for other options. So we'll go with hit and trial method. So first let's think they were consecutive. If we think them to be consecutive, then we have to go with, for example, if it was nth maximum for 630, then n plus 1th maximum for 420. Reason being, 630 is a bigger wavelength, it's a longer wavelength, it will spread more, and 420 being shorter wavelength will spread less. So if for 630 we have nth maximum, then for 420 it could be n plus 1, it could be n plus second, it could be n plus third, and so on. So we will solve for n plus 1. If n comes to be a whole number, then it will be n plus 1. However, if n is in fractions, then it would not be n plus 1. Then we'll test for n plus 2. So let's check what happens. So let's go with nth and n plus 1. The method will be, the formula for diffraction grating is, as we studied, it is d sine of theta is equal to n lambda for an order of maxima. So it will become d sine of 31 degrees is equal to n times the wavelength is 630. Then we have d sine of 31 is equal to n plus 1 times 420, and this is nanometer. No need to convert the nanometer, as later on it would be cancelled out. So now we have two equations whose left hand sides are equal. If the left hand sides are equal, then the right hand sides will be automatically equal. So we can say that d sine of 30 is equal to, it is n times 630, and also d sine of, sorry, it was 31. D sine of 31, it is equal to n plus 1 times 420. Now we can say that n times 630 nanometer is equal to n plus 1 times 420 nanometer. Obviously, nanometer will be cancelled out. That's why we have not converted. It will become 630n is equal to 420n plus 420. So this will give us 630n minus 420n is equal to 420. This will become 210n is equal to 420, and as a result n will be 420 over 210, it will be 2. So now what we got is the second order of 630 overlaps the second order of 630 order maxima of 630 nanometer overlaps with 420 nanometer with third order of with 2 plus 1th order of 420 nanometer. Now let's calculate D. It will become, now it will be D is to be calculated sine of 31 is equal to, for 630 it's second order, so 2 times 630 into 10 power, it will be obviously minus 9. So D is equal to 2 times 630 10 power minus 9 divided by sine of 31. Now if we use calculator, then we get 2 into 630 into 10 power minus 9 and divided by sine of 31. Answer comes to be 2.44 into 10 power minus 6 meters. According to this, the answer should have been C. So C should be the answer. It was a good question.